lesson number 7 follows the formulas from lesson number 6. And this one we're going to do interval estimations, which are also called confidence intervals. And we're going to need the TI-83 calculator and also, again, the normal distribution chart. From lesson number 6 that we just finished, we know the following formulas. We know that if it's a value question and we're talking about a sample, then the mean mu sub x bar is going to be the mean of the sample, and the standard deviation sigma sub x bar is going to be the standard deviation of the sample divided by the square root of the sample size. If it's a percentage question, then mu sub p hat is the mean and sigma sub p hat is the standard deviation, which is the square root of p times q divided by n. So the first thing you're going to do, if the question says sample, then you're going to have to do either this formula or this formula depending on what kind of outcome you're looking for. Again, if it's a value outcome where it's a data value, not a percentage, do this formula. If it's a percentage, we do this formula. Okay, so for this lesson, we're doing interval estimations. So we're trying to create an interval around the mean, and it's going to give us a certain amount of confidence. And here's what we're going to basically talk about. A couple definitions. Number one, point estimate. Point estimate is an estimate for the average of a population parameter. This is either the mean of a value or the mean of a percentage. So basically whatever the sample mean is in the question, that's also called a point estimate. Interval estimate is creating an interval around the point estimate, and these intervals are traditionally called confidence intervals, and they are used to estimate a range of values in which the population mean or percentage exists. We kind of do this on a daily basis. I'll give you an example of something that we basically do. Let's say somebody wants to pick you up to go out on a Friday night, and they want to pick you up at 7 o'clock. Everybody, now that would be an example of the point estimate. We always create intervals, a little left and a little right, of what time you think you're going to pick us up, that we think they're going to show up. So let's say we give 15 minutes, so 6:45 to 7:15 is within the range that we think the person is going to show up to pick us up. So that's the interval estimation, and it just gives us a little bit more leeway around whatever we think the average is going to be, and that's all we're doing in this lesson. So we're going to basically, in this class, we're going to do 3 confidence intervals. We're going to learn 3 types, the 90%, 95%, and 99% confidence intervals. There are other types, but we don't do those other types. Other types could be a 92, 4, 96, 98%, but we're only going to do the 90, 95, and 99. You'll see in a minute that there's really not much of a difference between creating the ones we want to versus other ones. By far and away, the most common one is the 95% confidence interval. I mean, it's not even close. That one's used most often. So let's do a little background here. So just follow along as we go, and you'll see I'm going to get you to where we want to be towards the end of the lesson. So we're going to do a little background. 90% confidence interval. So basically we have mean here, and we want to create a left and right of the mean so that we are 90% confident the population mean lies in this interval. Okay, so our goal is to find the z-score on the left and the z-score on the right that will create this 90%. So what we're going to do is we're going to take 90% and we're going to split 90% in half. So we're going to get 45% on the left and we're going to get 45% on the right. So that's going to create us a 90% confidence between this left and right endpoint. And what we're going to do is we're going to change the 45% to a probability or a decimal. So we're going to say 0.45 and 0.45. Then what we're going to do, we're going to go even further and we're going to add 2 zeros to the end, and you're going to see why in a minute. So 4,500 and 4,500, because what we're going to do is we're going to kind of do the opposite of what we've been doing all along. Usually we find that we get the z-score and then we look up the area. Now we're actually going backwards. We're given the area and we want to go backwards and try and find the z-score. So I'm going to take out the bell-shaped curve and we're looking at an area of 4,500. So we're trying to find in the 4 digits in here, we're trying to find where is there a 4,500. And we come across, if you notice right here, we notice there's a 4495 and a 4505. And if we go backwards, the 4495 is a 1.64 and the 4505 is a 1.65. So So 4495 has a z-score of 1.64. 4505 has a z-score of 1.65. We're trying to find, question mark, we're trying to find what is 4,500. Well, that's not right on the chart, so what we do is we do our best to say, well, if you notice 4,500 is exactly 0.0005 away from that and 0.0005 away from that. So we're basically halfway, right in between. And anytime you're halfway, you round up. So we're going to use the 1.65. So this z-score here would be 1.65. This one would be negative 1.65. And so in order for us to create a 90% confidence interval, if we have these z-score values, that will create a 90% interval from here all the way over to here, and that's what we're looking for. We're trying to find 90%. So let's do the next one. The next one asks for how do we create a 95? So we're going to leave that just for now. I'm going to come back to it in just a second. So now we're looking for a 95% confidence interval. So what we're saying is, if we have a mean in the middle, we want to create a left and a right, and we would like to find a z-score on the left and the right so that we are 90, between these two, we are 95% confident the population mean lies in this interval. So we're going to do the same thing. We're going to take 95%, we're going to cut it in half. So 95 cut in half is going to give us back 0.475 and 0.475. And okay, so 95 divided by 2. Okay, 47.5%. So 47.5% on the left, 47.5% on the right. As a decimal, that's 0.475 and 0.475. What we're going to do is we're going to add a 0 on the end, because our normal distribution chart goes out 4 decimal places, and so we add a 0 for the 4th decimal place. So now what we're trying to find is between 0 and a z-score has an area of 0.4750. So we're going to try and find the 4750 in here somewhere. So we go through and look, and we end up, if you notice right here, there is exactly a 0.4750. And if we go backwards, we're going to notice to the left, that's 1.9, and then up is 6. So a z-score of 1.96 will create that 4750 area. So this is a z-score of positive 1.96, and this is negative 1.96. Those z-scores will create a 95% area, and that'll give us an interval around the mean that we're 95% confident in. Okay, so let's try 99% confidence. Same basic idea. If our mean is here and we want a left and a right endpoint, that we're 99% confident in. So if we take 99 and divide by 2, we get 49.5% on either side. So we break this up at the middle. 49.5% is on that side and 49.5% is on the left. If we write those as decimals, we move the decimal 2 places over, we get 0.495. And we can add an extra 0 because that's what our normal curve has 4 decimal places. So now we're trying to find 4950. So we go through and we notice there's a 4949 right here, and there's a 4951 right there. So if we go backwards, 4949 is a 2.57, and a 2.58 is 4951. So if we go over here and we say, well, 4949 has a z-score of 2.57, and 4951 has a z-score of 2.58, we're looking for 4950, which is exactly halfway between those two. And so anytime you're halfway, you always round up. And we're going to say that then this is 2.58, and then the left would be negative 2.58. Those z-scores will create a 99% interval around the mean, so that we are 99% confident that this and this value will create 99% confidence in whatever our mean is. Okay, so going forward, we created a 90% confidence interval, and we said that that had a plus and minus 1.65 z-score. We had a 95% confidence interval, and that had a plus and minus 1.96 z-score. And we had a 99% confidence interval, and that had a plus and minus 2.58 z-score. You don't have to memorize these values, because the next thing we do after this lesson, in lesson number 8, is I'm going to show you how we can actually get these numbers off of another chart, so we don't have to memorize these numbers. But those are the numbers we're going to use up to this point. Okay, so now we have a few formulas going on. Let me go back just a smidge. For this lesson, the first thing we're going to have to do is we're going to have to remember the formula. If it's a value question, we use this standard deviation formula. If it's a percentage question, we use this standard deviation formula. And then in conjunction with which one we use there, we have to then go further and know that which confidence interval we're going to use. And that's how it works. So I'm giving you here the steps to create an interval estimate. Step 1, find the mean and standard deviation of the sample. Make sure that you use the correct formula for the standard deviation, depending if it's a value or a percentage question, like I just showed you a second ago. After we determine that, then we go on to step 2, which is using the z-score formula, which is data minus mean over standard deviation. We're going to substitute in values for the z-score, the mean, and the standard deviation. So when we have z-score is data minus mean over standard deviation, we're going to fill in for the z-score, we're going to fill in for the mean, and we're going to fill in for the standard deviation. And all that's left is basically then to find the data. And in finding the data, that's going to give us this left piece of data on this endpoint and this right piece of data on this endpoint, which will create our interval estimation around the mean. Okay, it sounds hard. It's really not as bad as you think. All right, so let's do some examples. We're going to go through nice and slow. Okay, and then finally, step 3. After we did the first 2 steps, we're going to solve for the data, and we're going to basically do this formula. And you can write it down. It's basically negative z-score times the standard deviation and add the mean. And then we do the positive z-score, multiply by the standard deviation, and also add the mean. And we'll create a confidence interval. So I'm going to do all 3 steps with you. Okay, here we go. We have a few examples we're going to do, and I think I'm just looking ahead. We have, I think, 5 examples. Yep, we have 5 examples, and we're going to, by the time hopefully you get to the 3rd example, these things go pretty well. All right, so here we go. Number 1. A random sample of 40 felons convicted of aggravated assault found the average length of sentence to be X bar, the mean is 54 months, and the standard deviation is 8 months. Okay, so here's some questions. What is the point estimate for mu? Now, point estimate means the guess as to the population mean. The point estimate is whatever the average is. So the average that they're telling you is 54 months for these 40 felons. So that's going to be the point estimate, 54 months. It's whatever the average is. We'd like to now B, create a 90% confidence interval around this 54 months for the felon sentenced. Okay. So B, step 1. Find the mean and standard deviation. So the mean, now this is going to be, you have to ask yourself, is this a value question or is this a percentage question? We're talking about conviction, and so we're talking about time, which is months, and that's obviously value. So we're going to say The mean, mu sub x bar, is 54 months. The standard deviation, sigma sub x bar, is the standard deviation that they tell us, which is 8 months. But we have to divide that by the square root of the sample size, and the sample is 40 felons. All right, so in our calculator, we're going to put in 8 divided by radical 40. And we're going to get back a 1.26 standard deviation. So that's our mean. That's our standard deviation. This standard deviation in the example is now not going to be used anymore. We still haven't created the confidence interval now. We just did step number 1. So step number 2 is using the z-score formula. We're going to fill in for the z-score, the mean, and the standard deviation. So the z-score is based on the confidence interval. So we want a 90% confidence interval. We found earlier, I'm just going to scoot back in a previous thing, 90% confidence intervals have a z-score of plus and minus 1.65. So we're going to put in plus and minus 1.65. Okay, that's based on the 90% confidence interval. I don't know what my data is, but I know my mean is 54 months. That's my mean, and my standard deviation is 1.26. So, how do we solve for that data? What you do is, how do you undo a division? This is being divided. So you undo a division by multiplying, and then how do you undo the subtraction? You undo the subtraction by adding. So what we have here is we have a left piece of data, left of the mean, and we have a right piece of data, right of the mean. The negative z-score will be obviously left of the mean. So we choose the negative on the z-score first. We then want to undo to solve for the data. So we get rid of the division by multiplying, and then we get rid of the subtraction by adding. And all we do to get the right piece of data is do the exact same thing, but we use the positive z-score. So positive 1.65 times 1.26, and then we add 54. So the same thing, undo the division by multiplying, undo the subtraction by adding. So in our calculator, we're going to put in negative 1.65. We're going to multiply that by 1.26, and we're going to add 54. 51.92. Then we're going to do the same thing with a positive 1.65. So we're going to multiply by 1.26, and we're going to add 54. 56 point, round it, 0.8. Okay. So that's part B. That is the confidence interval. So now part C asks you, okay, part C says explain your answer. So we're going to say something along the lines of, we are 90% confident the average length of a sentence is between 51.92 and 56.08 months. We're 90% confident that that is the range of where the population average will be. So we're covered ourselves. Now remember, 54 months is in the middle. 54 months is the mean. So we're going a little left and a little right of that. So for part D says, what is the error associated with the confidence interval? Well, that's the difference. So the error, if we take the mean 54 and then we surround it by the confidence interval, so this is the average, we want to know how much of a difference there is between the average and these two things we just created. And if you notice, between 54 and 56.08 is positive 2.08. And that's all we need, because if you notice, between 54 to this one is going to be negative 2.08. It has to be the same. Just one's positive, one's negative. So that plus and minus 2.08 is the error. Now I put a line there because this error is called one of two types. So I'm going to give you some notes over here. Maximum error is one of the types. That is the name used for 90% or 99% confidence intervals. And then there's something called margin of error. and that is the name used for 95% confidence intervals. And if I scroll up, you notice we wanted to create right here a 90% confidence interval. So this error down here is going to be called a maximum error. Okay, that was part D right there. E then asks, what percentage of the time is the interval found in part B to be wrong? Well, if you're 90% confident, that means you're 10% not confident in the interval you just created. And so there's a 10% chance that the interval you just created is wrong. So basically what we're saying is, if the average is 54, you're saying, well, are you sure? Well, we're 90% sure that it's actually between these two values, which surround the average of 54. All right, so let's do another one. 2. There is a 76% recapture rate for escaped convicts in the United States based on a sample size of 6,150. Okay, so of all those that escape, 76% are recaptured. Okay, what is the point estimate for P? Well, the point estimate is whatever they tell you, so in this case that's 76%. Okay, we would like to create a 95% confidence interval for the recapture percentage for all escaped convicts. So we want to do a 95% confidence interval that'll then be a little left and a little right of the average of 76. Okay, so step number 1, we need to find the mean and the standard deviation, and this is a percentage question. So the mean is mu sub p hat, that's going to be 76. The standard deviation is then the square root of p, 76, times q, so 76% are recaptured, 24% are not, and we're going to divide that by 6,150, which is our sample size. So there's our mean and standard deviation of percentage. So in our calculators, we're going to put in the square root, 76 times 24, we're going to divide by 6,150. We're getting back 0.54. Okay, so step 1, find the mean, find the standard deviation. Step 2, using the z-score formula, fill in for the z-score, the mean, and the standard deviation. The z-score is based on the confidence interval. For a 95% confidence interval that we found earlier in this lesson, that was plus and minus 1.96. The mean we just found to be 76. The standard deviation we just found to be 0.54. Okay, now basically the same thing. We have a left piece of data left of the mean. We have a right piece of data right of the mean. So we're going to say the negative 1.96 z-score is going to be obviously negative, so left of the mean. You want to undo this division, so we're going to multiply by 0.54, and then to undo the subtraction, we're going to add. You do exactly the same thing on the other side, except we use the positive 1.96. So in our calculator, go over here, we're going to put in negative 1.96, we're going to multiply by 0.54 and add 76. Okay, we get 74.94. And then we do the exact same thing, but we put in positive 1.96, multiply by 0.54, and add 76. 77.06. Okay, and that's our confidence interval. Okay, so that's part B. Part C says, please explain your answer. So we're going to say we are, or I am, 95% confident between 74.94 and 77.06% of convicts are recaptured. And that's an interval that surrounds the initial average, which was found to be 76%. Part D, I'll scoot up. What is the error associated with this? What I do is I just simply take the mean that was in the original problem, which was 76, and I put it between my intervals, and I find out how much do I have to add or subtract to get the endpoints. And you notice 76 to 77.06 is additional 1.06. And then you'll notice that if I subtract 1.06, I will get those answers. So that is the error. So you're going to say it's plus and minus 1.06. And this is called a specific type of error. And since it's a 95% confidence interval, we call it margin of error. And that's the error. You see this a lot on television. On television, they usually don't write these confidence intervals with a left and a right. They usually just give you the mean, 76, and then they give you the plus and minus 1.06 error, and then they actually name it, in this case, margin of error. So the good news is you now can read those. And if you add 1.06, you get 77.06. If you subtract, you get 74.94. And margin of error, they say margin, which tells you they use a 95% confidence interval. So they're 95% confident in the left and right endpoints of where the population percentage exists. So most things in the world are done with a 95% confidence interval. And then finally, the last one says, what percentage of the time is this interval wrong? Well, then you're just going to say, well, if I'm 95% confident, that means I am 5% not confident. There's a 5% chance that that interval is wrong. So in real life, when they say margin of error, whatever interval they give you, there's a 5% chance that what they're telling you is actually not right. The population percentage is not within the interval that they're describing to you. All right, let's take a look at number 3. A financial advisor's list of clients has an average portfolio value of a mean of 87,350 and a standard deviation of 25,800 based on a sample size of 154 clients. This, you would say, is a value outcome because we're talking about dollars. Okay. What is the point estimate? That's whatever the average they're telling you is. So that would be 87,350. Okay. B. Let's create a 99% confidence interval for the average portfolio value. So I need a mean. This is a value, so we're going to say mu sub x bar. That's 87,350. I need a standard deviation. So we're going to take the standard deviation 25,800 and we're going to divide it by the square root of the sample size, which is 100 right here, 154 clients. So 25,800 divided by the square root of 154. 2079.02. 2079.02. So there's our mean and standard deviation. Okay, we want to find a confidence interval. So 99% confidence interval has a z-score of plus and minus 2.58. So we're going to say that's data minus the mean of 87,350 divided by the standard deviation we just found, 2079.02. So we're going to take the negative 2.58. We're going to multiply it by the 2079.02 to get rid of the division, and we're going to add 87,350. That'll give us the left endpoint. We're then going to take the positive 2.58. We're going to multiply and add the same values. All right, so here we go. Negative 2.58 multiply by 2079.02, add 87,350. Okay, 81986.13. That's one of them, and then 2.58 we multiply by 2070, and we add 87,350. Okay, 92, 713.87. So that's my confidence interval. So okay, so I'm 99% confident that the average of portfolio value of all of my clients is within that interval there. Okay, so part C, you would say we are 99% confident average portfolio value is between 81,986.13 and 92,713.87. We're 99% confidence in that. D, what is the error? So if I take the average, let's see here. So if I go over here on the side and I take the average, which was 87,350, how much do I have to add and subtract to get those endpoints? So how about my calculator? I simply put in 92,713.87, and I get rid of the 87,350. That'll give me the difference, and I'm looking at a 5,363.87. Now you could have done it the other way too. You could have taken the 81,986.13 other endpoint and subtracted the 87,350. And what you're going to get is just the same answer, just in the negative. So that's what you subtract, 5,363.87. So either one of the endpoints. Or some of my students take the difference between the left and the right and then divide by 2. I mean, it doesn't matter any way you do it. I like taking the mean and subtracting either endpoint. Doesn't matter which one. And so you're going to say plus and minus 5,363.87. And this is a 99%, so we're going to call it maximum error. And then E, what percentage of the time is this interval going to be wrong? 1%, because it's a 99% confidence interval. Hopefully by now, hopefully you're seeing a lot of similarities from one question to another. There's 2 more to go. So what I want to do is I want to show you these, and I think it's a good idea that you pause the video and try to do these questions yourself, and then come back and see if you got the right answer. So here we go. 4. How much customers buy is a direct result of how much time they spend in a store. More time they spend in a store, you would probably think they spend more money. That makes sense. A study of national average shopping times in a large houseware store found the average to be 8.3 minutes with a standard deviation of 2.3 minutes if a woman is with a female companion, and an average of 4.5 minutes with a standard deviation of 1.4 minutes if the woman is with a male companion. Now that kind of makes sense, because it seems like the women probably like to shop and maybe the guy doesn't. But that's just a generality. So here we go. Create a 90% confidence interval for the average shopping time for a woman with a female shopping companion. All right, so for part A, step 1, let's find a mean and let's find a standard deviation. Shopping time is going to be a value, so we're going to say mu sub x bar. So the mean shopping time for a woman with a female, if I go up here and I say woman, okay, the average shopping time is 8.3 for a woman with a female companion. And the standard deviation is 2.3, but it's a sample, so we have to divide that by the square root of the sample size. So it says how many customers found national average. Okay, so we assume what's not in the question here, and I'm just going to write it in. We assume that the sample size, and they would have to give this on the book, we assume the sample size is, let's say, 55. So 55 people with female, and also female, male. So 55. So let's divide by the square root of 55. Okay, so right here. 2.3 divided by the square root, 2.3 divided by the square root of 55.31. Okay, so we would like a 90% confidence interval. So we need a z-score. That z-score is plus and minus 1.65. That's the z-score for 90% confidence intervals. Data minus the mean of 8.3. Standard deviation we found to be 0.31. So we're going to say negative 1.65. We're going to multiply by the 0.31. And we're going to add the 8.3. And then we're going to do the same thing with the positive 1.65. Negative 1.65 times 0.31, add 8.3. 7.79 to 1.65 times 0.31, add 8.3. 8.81 minutes. So we're 90% confident that the average shopping time for a woman with a female companion is going to be within that interval of time. Okay, so for part B, they're asking create a 95% confidence interval for the average shopping time for a woman with a male shopping companion. So we still need to go down here. We still need a mean and a standard deviation. This is a value question. So the mu sub x bar and sigma sub x bar. If we read the question, it says female companion, okay, the average is 4.5 minutes. Standard deviation is 1.4 for a woman with a male companion. So we're going to go down here and say 4.5 minutes is the average, and the standard deviation is 1.4, but we're going to divide that by radical 55. Okay. So 1.4 divided by square root of 55. All right, 0.188, let's call that 0.19. That's the standard deviation. So we need a 95%, so we're going to say plus and minus 1.96. Data minus mean over standard deviation. We're going to take the negative 1.96 and multiply by the 0.19, add 4.5, then positive 1.96. Okay, in our calculator, we're going to put in, scoot that over. Okay, negative 1.96, we're going to multiply by 0.19, we're going to add 4.5. 4.13, then positive 1.96, we're going to multiply by 0.19, we're going to add 4.5. 4.87. Okay, now we're 95% confident the average shopping time for a female with a male companion is in that interval there. Part C, scoot up here, asks what are the errors associated with each confidence interval from A and B? All right, so let's do A. The error, so the average was 8.3. If we take the average of 8.3, how much do we have to give and take to get those actual intervals? And if you notice, the difference here is going to be 0.51 and negative 0.51. So we'd say the error is going to be plus and minus 0.51, and because this was a 90% confidence interval, we're going to call that maximum error. And for this question, the average was 4.5, so if we put a 4.5 here, how much do I have to add and subtract? The difference between 4.5 and 4.87 is 0.37. And if we subtract 0.37, we'll get back the difference between 4.13 and 4.5. So that's the error. So we're going to say the error is plus and minus 0.37. And because this was a 95% confidence interval, we're going to call this margin of error. And we've answered all of the questions for that one. All right, let's look at one more. A sample of 864 Americans found that 19% are in favor of making smoking totally illegal. Okay, we looked at that one earlier from another lesson. So this is definitely a percentage question, and we go through the question. It says, what is the point estimate for P? You're going to say 19%. Let's create a 99% confidence interval for the actual percentage of Americans. Okay, so 99 is a z-score of 2.58. Okay, data. Okay, we need a mean and a standard deviation. So over here on the side, we're going to say the mean, mu sub p hat, that's 19. The standard deviation, sigma sub p hat, is the square root of p, 19. So 19% feel it should be totally illegal. That means 81% don't feel that way. And we divide by the sample size of 864. So in our calculator, the square root 19 times 81 divided by 864. Okay, 1.33. That's our standard deviation. So if we go back, 99%, that is the z-score. The mean is 19, the standard deviation is 1.33. So if we take negative 2.58 and we multiply by the 1.33 to get rid of its division, and we add the 19 to get rid of its subtraction, we'll have that value. And the positive 2.58, we multiply by 1.33, and if we add 19, we'll get that one. Negative 2.58 times 1.33, add 19, 15.57. Okay, 2.58 times 1.33, add 19, 22.43. So we are 99% confident the percentage of people in favor of making smoking totally illegal is between 15.57% and 22.43%. We're 99% confident in that. So that would be your answer to part C. What is the error? Okay, if we take 19%, how much do I have to add and subtract to get those endpoints? So if we add 3.43 and subtract 3.43, okay, you can put that in your calculator, just put that number, 22.43, and subtract the 19, and you'll get back to 3.43. So for part D, the error is plus and minus 3.43%. Or just 3.43, and this was a 99% confidence interval, so we're going to say it's maximum error. E, what percentage of the time is this interval going to be wrong? 1%, because it's a 99% confidence interval. Okay, so some of the stuff you see in the, like when it comes to politicians and let's say coming up soon as an election. And let's say candidate A, before the election is held, has a 41% polling rate. Candidate B has a 38% polling rate. And candidate A is plus and minus 4% margin of error. And candidate B is plus and minus 4% margin of error. So some of the mistakes that a lot of times on television other people make are, who's leading the election, who would win if it were held tomorrow? Well, everybody's going to say candidate A because they're leading 41 to 38. But that's not really true because the margin of error creates confidence intervals. So candidate A is sitting at 41%, but if you add and subtract the error, add 4, subtract 4, we're 95% confident that the range of percentage for candidate A is going to be between 37 and 45. So on election day, we're 95% confident somewhere in that range candidate A is going to sit. Candidate B starts off a little lower, but when you add and subtract the 4, so if I subtract the 4, you get 34, and when I add the 4, you get 42, we're 95% confident, because it says margin of error, that that is the range for candidate B. So technically, we can have, a pretty extreme election if we take the top for A and the bottom for B, which is possible because it's within the margin of error. Then technically candidate A can be leading as much as 11, or if you flop it, candidate B technically could be winning by as much as 5. So the question then is, who's leading the election? And this would be what they call on television either too close to call, sometimes they say that, or they'll say it's a statistical tie, meaning either candidate can be leading, we don't know, or they call it a dead heat. Remember, this is a prediction what's going to happen. So obviously when the election night, then you'll see the actual results, but going up to election night, there's polling, and this is the polling, so you have to keep into account the margin of error. And remember, since it's margin of error, that means you're 95% confident, so that means we still have a 5% chance that all of the stuff that we're talking about is still wrong, because we're only 95% confident. So 5% chance, none of this is even correct. It could be different. But we are 95% confident, which is a pretty high confidence level. But we would know which candidate is technically leading. There could be a situation where, candidate A, candidate C has 50% and candidate D has 30%, and the margin of error is, 4%. Then it doesn't matter which way you slice it. Candidate C is going to win no matter what, because the lowest candidate C is going to get high is 54, the low is 46. The high candidate D is going to get, if you add the 4, is going to be 34, and the low is 26. And even on the low end, candidate C still wins. So then you'd say candidate C is definitely winning that one. But that's part of how margin of error and all these confidence intervals is used on a every 2-year cycle when we have elections. 2-year cycle when it comes to the House of Representatives. All right, so the next one. If you notice, just some behind-the-scenes background information here. If you notice, the larger the confidence interval, the wider the interval around the mean. This is due to the z-score being larger as the confidence level goes up. So there are 2 ways to create more confidence in the estimation of the populace. Pick a larger confidence interval. So if you notice, if this is the mean, 90% confidence interval is negative 1.65 and positive 1.65. If you want a larger 95% confidence interval, then you end up going a little further out. And then of course if you want even larger 99% confident, then you end up going to negative 2.58 to positive 2.58. So if you want more confidence, increasing your confidence percentage is not the way to go. Because basically all you're then saying is, I just want to make it wider. So what that means is, if, let's say, a teacher says, I think the average on test number 1 is going to be an 80. And the students say, are you confident? The teacher could say, well, I'm pretty confident that the average is going to be, let's say, subtract 4 and add 4. I'm pretty confident it's between 76 and 84. And if the students then say, can you be more confident? Say, yeah, I can be more confident. I just make it wider. Subtract 10 and add 10. I'm more confident that it's between 70 and 90. But that's just because you made the interval wider. And that's just, silly, because you're just making it wider, which is creating more error. That's you are more confident in that, but that really doesn't help statistically. Or select a higher sample size. And basically I asked you here before, what's better? A sample size of 30 or a sample size of 50? Well, 50 is better because there's more information. more information is going to be a more accurate sample, which leads to a more accurate statistic or confidence interval. So that's just general information. Or if you notice the standard deviation, always divide by radical sample size. The bigger this denominator becomes, the smaller the entire fraction becomes, and the smaller means smaller error. So if you increase the sample size, that will reduce the error associated with it. So the question asks, there are two ways to create more confidence. If you want to create more confidence, pick a larger confidence interval. That's not a good way to go. Or simply ask more people. Asking more people gives you more information. More information gives you more accurate, which gives you more confidence. That's the better way to go. Is pick a larger sample size. So that's interval estimation. Make sure you click on the homework and take care of any homework, and any questions, send me an email.